Pluto is a distant and dim, relatively small astronomical object that was once considered part of our solar system. However, recent and surprising announcements by leading space experts Neil deGrasse Tyson and Mayoku have brought Pluto back into the spotlight. They suggested that this remote body could potentially be on a likely crash course with Neptune. They aren't merely hypothesizing, they're issuing a warning. This miniature world may be heading straight for a catastrophic encounter with Neptune. But how could such a thing be possible? And what would the aftermath be if an enormous impact like that truly took place? Are we seeing an odd cosmic illusion? Or is something far more tangible, and far more alarming, speeding toward us? Pluto's path comes dangerously close to Neptune's. Neil deGrasse Tyson and Mayoku are raising the alarm. If there's even a slight adjustment, we could be facing a devastating planetary accident. Could Earth also be in danger? More importantly, how could such a cosmic event ever occur? Come along with us as we investigate the potential outcomes of a collision between Pluto and Neptune. Pluto, once officially a planet but later downgraded to a dwarf planet, remains a source of intrigue in the vast universe. Current models from leading researchers show that Pluto's path is dangerously close to Neptune's. Famous astronomers Michio Kaku and Neil deGrasse Tyson are warning the world about a possible dangerous interaction between these two bodies, which could pose a significant threat to Earth. However, how could this scenario take place? Pluto's journey around the Sun is unlike any other orbiting body in our solar system. It takes an incredible 248 Earth years to complete one revolution. Since its discovery in 1930, it hasn't even made one full orbit. Still, the intrigue doesn't stop there. Pluto's orbital path is highly stretched out, much more so than the generally circular paths of the main planets. The 17 degrees tilt of its orbital inclination in comparison to the plane of the Sun is even more fascinating. This trajectory is far more irregular than those of the other planets, adding layers of complication to Pluto's movement. The fact that Pluto's path intersects Neptune's orbit is probably one of the most fascinating aspects of it. For about 20 years in each orbital cycle, Pluto is actually closer to the Sun than Neptune, defying what we'd expect based on their standard positions. The usual concern arises: why haven't they collided? The gravitational effects of nearby celestial giants provide the solution. Studies into Pluto's path began soon after it was found. Early astronomers attempted to make sense of its odd orbit. While most planets follow loops that align with the Sun's plane, Pluto's trajectory is slanted and uneven. The puzzle grew deeper when scientists realized Pluto's orbit crosses that of Neptune. Despite these odd features, Pluto's motion remains stable, demonstrating the subtle complexities of space mechanics. Understanding how three celestial bodies like Pluto, Neptune, and the Sun interact with one another through gravity is at the heart of the three-body problem. It's like predicting future positions based on their initial placements and mutual gravitational pulls. This complexity demonstrates how Pluto's movement, Neptune's orbit, and the Sun's pull all function within an interlinked system in the case of Pluto. Terms like asynchronous oscillation, orbital drift, and the VZK wobble are key to decoding this riddle, as highlighted by astrophysics experts. Asynchronous oscillation is what keeps celestial bodies on their stable paths. This means that when Pluto passes through Neptune's path, it is at least 90 degrees away from Neptune, a safe angular buffer that prevents a crash. This is the case for Pluto and Neptune. In contrast, orbital drift involves a body's vertical displacement as it circles. For Pluto, this suggests that when it draws near Neptune or another large planet, it is far above their orbital paths, adding another safeguard against potential impacts. Another important factor is the VZK wobble, named after researchers Zell, Kai, and Koku, who studied the gravitational interactions of space objects. It explains how Pluto, Neptune, and the Sun, three massive objects, exert forces on one another, influencing their movements. In Pluto's situation, the VZK wobble offers insight into why its orbit near the Sun appears erratic. Even though its path may seem unstable, this wobble helps keep it smoothly orbiting over very long periods. The VZK wobble shows that while space may seem chaotic and unpredictable, underlying principles still maintain a degree of stability. These forces keep Pluto moving in the same direction, preventing Neptune from colliding with Pluto or veering off course. This three-body dynamic is vital to understanding how orbits shift due to gravitational interference. Studying it gives us more clarity about Pluto, our planetary group, and even distant galaxies. Computational models from the 1980s indicated that while Pluto's orbit is stabilized by certain features, it still exhibits unpredictability. Minor changes in starting conditions can cause major deviations over centuries. Still, Pluto's orbit has remained steady over remarkably long durations. We are now better able to observe how the massive planets Neptune, Jupiter, and Saturn affect Pluto's orbit around the Sun, thanks to automated data. Pluto and Neptune have a unique rhythm to their orbits. Neptune completes 3 laps for every 2 laps Pluto completes. This synchronicity helps preserve Pluto's route. But Neptune isn't the only player. Jupiter's powerful gravity plays a major role in keeping Pluto's path stable. Saturn also plays a role. According to research, Jupiter's mass is sufficient to assist Pluto in maintaining its trajectory for perhaps billions of years. It would appear that Neptune, Jupiter, and Saturn are working together to ensure Pluto's safe passage through space. These unusual but vital systems are crucial to keeping our solar system stable. Space would be much more chaotic without them. Objects like Pluto might crash into others or be expelled from the system, creating chain reactions across the cosmos, particularly in Pluto's case, and concerns about future encounters with Neptune. Understanding its movement is essential. Our understanding of the dynamic and ever-evolving nature of our planet's family is improved as a result. Pluto's case shows how even seemingly unstable orbits can achieve harmony through complex gravitational and kinetic balances. It also highlights the need for constant observation and analysis of these anomalies to better understand our place in the universe. Exploring the outer realms of space often brings us face to face with the strange nature of celestial phenomena. Pluto's orbit is a testament to the delicate balance that governs celestial motion. Its irregular path, once seen as an anomaly, now serves as a critical case study in gravitational mechanics. As our instruments and data analysis techniques improve, so does our ability to decode the mysteries of distant bodies like Pluto. Every discovery about its trajectory brings us one step closer to understanding the invisible threads that hold our solar system together. Yet, despite the stability ensured by gravitational interplay, the fear of chaos remains. Astronomical systems are sensitive to change, so much so that even a minor nudge from a passing object or a subtle shift in mass distribution could initiate a cascade of orbital disruptions. This is why modern astrophysicists keep such a close eye on trans-Neptunian objects and distant dwarf planets. Any new entrant into the Kuiper belt could interact with Pluto's path in unpredictable ways. The stakes aren't just theoretical. A disruption in Pluto's path, though unlikely in the near term, could alter its long-term relationship with Neptune, Jupiter, or even Earth. While the odds of a direct impact with any planet are extraordinarily low, the mere possibility underscores the importance of predictive models and real-time monitoring. As space agencies like NASA and ESA continue to launch more sensitive probes and telescopes, our ability to track these bodies with greater precision will only improve. Already, simulations run by the Jet Propulsion Laboratory and independent observatories have begun exploring hypothetical futures where minor changes lead to major cosmic consequences. Some models predict that under extreme conditions, such as a close flyby of a rogue planet or a black hole, Pluto's orbit could become dangerously erratic. While these scenarios are currently in the realm of science fiction, the underlying physics is sound, and the outcomes, if they ever came to pass, would be profound. This is why Pluto has become more than just a curiosity. It is a bellwether. It tells us not just about the history of our solar system, but about its potential futures. It reminds us that the cosmos, though vast and seemingly silent, is a place of motion, tension, and invisible drama. Each orbit, each gravitational pull, each passing comet, contributes to the ever-changing narrative of space. In a universe defined by chaos and order in equal measure, Pluto stands as both a mystery and a marker of cosmic resilience. It is not merely a frozen world at the edge of our solar system, it is a dynamic participant in an ancient, ongoing ballet of forces. Its survival, its motion, and its story are all deeply woven into the fate of the solar system itself. Perfect representation of such irregularity. The concept of orbital chaos, which refers to how orbits are highly sensitive to their starting conditions, is clearly at play here. This indicates that Pluto's long-term path can be significantly altered by even minor adjustments to its speed or position. Using computer simulations has greatly aided scientists in examining Pluto's behavior. These tools use complex formulas to replicate how Pluto and planets like Neptune interact through gravity. By tweaking initial variables, researchers can observe how even minor adjustments may completely change Pluto's destination. In the 1980s, a startling aspect of Pluto's orbit was revealed by digital models. Despite built-in stabilizing factors like asynchronous oscillation and orbital drift, Pluto's journey can still act unpredictably. A slight difference in its starting location or velocity could produce vastly different outcomes in just a few years. Nevertheless, Pluto's path has held steady over billions of years. This indicates that underneath its erratic appearance lies a hidden consistency. It is still extremely difficult to predict the motion of celestial objects, particularly those with erratic orbits like Pluto's. Long-term predictions are difficult to make because of these systems' inherent instability. While mathematical models are excellent tools for understanding and predicting space dynamics, they also show our limitations. These calculations rely heavily on accurate starting values, and even a small error can lead to drastically different results, making precision very difficult. Pluto also symbolizes the constant transformation and movement that takes place within the cosmos, in addition to the unpredictability of its orbital paths. Despite humanity's considerable achievements in astronomy, Pluto's unusual behavior reminds us how much we've yet to learn. We gain a better understanding of the dynamics of the solar system by studying how massive planets influence Pluto's movement. It shows that each planet's mass and location can significantly influence others. So why are high-profile astrophysicists suddenly worried about a potential Pluto-Neptune impact, despite all the cosmic mechanisms designed to avoid it? Neil deGrasse Tyson, a prominent public astronomer and well-known scientist, provides a novel perspective on the mystery surrounding our planets, particularly Pluto's peculiar history. Tyson, known for advocating Pluto's reclassification as a dwarf planet, provides insightful commentary on how our understanding of orbits and the solar system evolves over time. He doesn't think Pluto's status change is disrespectful, rather, he sees it as a necessary change brought about by expanding scientific knowledge. Tyson believes that learning and adaptation are central to grasping complex orbits. He views trajectories like Pluto's as a sign of how much more there is to discover. The wonder behind such mysteries keeps astronomy exciting. Yet, while Tyson is generally optimistic, his view of a potential Pluto-Neptune collision is far more sobering. His concern about Pluto's fate, once an official planet, stems from his awareness of orbital instability. He acknowledges that Pluto has remained safe up to this point, but even small changes over time could result in disaster. Pluto's orbit, especially its overlapping section with Neptune, forms a fragile cosmic rhythm that may not last forever. Tyson argues that even minor shifts in Pluto's movement could lead to major consequences. Over thousands or millions of years, such disturbances could cause chaos or even a direct collision. Even though this isn't a threat right now, it could happen far beyond the time of human civilization. Still, Tyson's cautious tone stresses the importance of continued vigilance and further study of Pluto's orbit. Tyson isn't alone. Michio Kaku, a world-renowned theoretical physicist, also sees the possible mayhem that might result from planetary interactions. Kaku, like Tyson, is awestruck by the vastness of the universe, but he is also aware of the fragile equilibrium of planetary systems and the possible unpredictability of their outcomes. Both Kaku and Tyson emphasize the importance of relentless exploration into the invisible forces guiding orbital paths and the long-term future of our solar family. In conclusion, Pluto's circumstances demonstrate the dynamic nature of our understanding of the universe. New questions emerge with each new finding. The remote possibility of a Pluto-Neptune impact humbles us as astronomy advances. Surprises abound in the cosmos, and even seemingly tranquil planetary paths can undergo significant changes over time. Pluto's lessons inspire us to keep looking up, and to keep wondering what secrets the stars have yet to reveal. As we observe the cosmos, it's clear that the vast, seemingly unchanging expanse of space is, in fact, a dynamic environment. The interactions between planets, moons, and other celestial bodies are more intricate and delicate than we could have imagined. Pluto, once considered the outermost planet, continues to surprise us with its erratic orbit and the potential it holds for future discoveries. Its journey around the Sun is far from simple, and the mysteries surrounding its orbit are far from resolved. While Pluto's orbit appears stable now, the possibility of unforeseen changes in the distant future invites deeper reflection on our place in the universe. What if, one day, the path of Pluto does intersect with Neptune in a way that can't be predicted or avoided? Would it be the end of Pluto as we know it, or would it mark a new chapter in our understanding of celestial mechanics? The more we study these distant bodies, the more we realize how much we don't know. Each breakthrough in our understanding of space opens new doors to questions we had never considered. For instance, Pluto's relationship with Neptune isn't just about the potential for collision, but also about the deeper forces at play in the cosmos, forces that govern not only the movements of planets but the very fabric of space and time itself. As scientists like Tyson and Kaku continue to push the boundaries of our knowledge, the mysteries of Pluto and its place in the solar system will undoubtedly continue to fuel curiosity. In many ways, Pluto serves as a metaphor for the limits of human knowledge. It's a reminder that no matter how much we've learned, there are always more questions to ask, more discoveries to be made, and more surprises to encounter along the way. In the end, the study of Pluto and its erratic orbit serves as a humbling experience for all of us. It shows that even in a world of advanced technology and ever-expanding knowledge, the universe still holds many secrets. And perhaps, that's what makes the pursuit of astronomy so thrilling. No matter how much we learn, the stars continue to call us with their mysteries, waiting for us to explore them.